Okay, today we are covering section 6-7 on solving radical equations and inequalities. I'm thinking we're not doing the inequalities, just the radical equations. So the steps involved in this are, first of all, you have to isolate the radical on one side of the equation. It might be a square root, like this first example. It could be a cube root, fourth root, but you're going to isolate it on one side of the equation. Get it by itself. Then you're going to raise each side of the equation to a power equal to the index of the radical. And I know that sounds complicated. All that means is because this is a square root, I'm going to square it. I'm going to square both sides. If this was a cube root, I would cube both sides. But you have to get the radical by itself first. Then you solve the resulting polynomial equation. And then you check your results. And this part right here, really important, because sometimes what happens in the process of solving a radical equation, you get what's called an extraneous root, which is an extra root, and it doesn't work. So it's really important that you always check your solutions. So for this first example, the first thing you're going to do is add 1 to both sides, because you have to isolate the radical first. So when you do that, you get the square root of y minus 2 equals 6. Next step is we are going to undo square root. So we square both sides. When you square the square root, it cancels out and leaves you y minus 2. 6 squared is 36. And then you add 2, so we get 38. Now we have to check our answer. So when you check your answer, you're going to plug the 38 back into the original equation. So we get the square root of 38 minus 2 minus 1. And we are checking to make sure that we get 5. So 38 minus 2 is 36. The square root of 36 is 6. And 6 minus 1 is 5. It works. This is my answer. Not too bad. Next question. Now you'll notice on this one, remember the first step is to isolate the radical on one side of the equation. We have 2 radicals. So what do we do then? Well, this is a multi-step problem. You can't get it by itself because you have 2 of them. So what you're going to, but I have 1 of them by itself. So we're going to start with that. So I'm going to actually undo, I'm going to square both sides, but I have to square the whole side. So be careful on this right side. It's going to trick some of you, so you got to watch out for this. When I do this, when I square the square root, I get x minus 12. But on this side, you either have to FOIL it or put it in a box. So when we do that, we get 2 times 2 is 4. Here we get minus 2 root x. Here we get minus 2 root x. And here the square root of x times the square root of x. You're squaring a square root, it cancels it, leaves you an x. A negative times a negative is positive. So we get this. So I have 4 minus 4 root x plus x. So you'll see I still have a square root in my answer. So that's kind of a drag. So I go back to step 1, which says to isolate the radical on one side of the equation. So I just have to go through the process again. So now we have to isolate this term right here, which means I'm going to get rid of, I need to subtract the 4 from both sides, and I need to subtract the x from both sides. So what do I get? The x's are gone. Negative 12 minus 4 is negative 16. Those are gone. That's gone. So we have negative 4 root x. So I have this equation to solve. Now I'm still trying to isolate the square root of x, so I divide both sides by negative 4. That cancels. So I have the square root of x equals negative 16 divided by negative 4 is a positive 4. And now I need to undo, I need to undo the square root, so I square both sides. I'm going to put the x on this side. So I get x equals 16. So the process, let me run through that again. You isolate one of the radicals, so then you square both sides, but in many cases you might have to do a box. And then or FOIL. And then once you do that, you should only have one radical left. And then you have to go back to the first step again and do it again. I get 16, but let's check our answer. So I go back to the original equation and I plug in a 16 minus 12. And over here, I'm checking to see if this works. I'm going to put a question mark here because I'm checking it. So I get the square root of 4. Over here, I get 2 minus the square root of 16 is 4. So the square root of 4 is 2. And 2 minus 4 is negative 2. Uh-oh, that's not true. So this was the only solution I got. But when I checked it, it didn't work. So what does that mean? Hopefully you're thinking, no solution. Now, this is why I said it's really important that you check your answer, because if you don't do that, you would just write down 16 and be happy you got an answer and go on and you'd find out you were wrong. I want to show you something else with the calculator to kind of demonstrate this idea of no solution. In y1, I graphed the left-hand side, the square root of x minus 12. And in y2, I graphed the right-hand side, which was 2 minus the square root of x. Now, because this would be the parent graph shifted 12 to the right, I messed with the window a little bit. I changed my x min to 0 and my x max to 20. I left my y min and y max negative 10 to 10, and I hit graph. So the one that you see right here that is going up, notice it's shifted 12 to the right. That's the left-hand side of my equation. The 2 minus the square root of x is the parent graph reflected over the x-axis, and then it's raised up 2. So that's what you see here. Notice they don't cross. They don't cross, they don't intersect, which illustrates that there's no solution. So that makes sense. All right, so you have 2 problems to try. So I want you to go ahead and try them. Don't forget to check your answers. So pause it, try it. Okay, so go ahead, and I provided the work here. I'm not going to talk through the whole explanation. You might want to pause the video and check the work before you go on. All right, so what if the problem is given in this format? Now, don't let this kind of freak you out, because we know what this means now. So I'm going to change the color of my pen back. So remember that this just means cube root. So you can rewrite this. If you want to, you can leave it with that rational exponent, or you can rewrite it as the cube root of 3y plus 1 plus 5 equals 0. So I'm going to start by isolating the radical. So we get the cube root of 3y plus 1 equals negative 5. Then to undo cube rooting, you have to cube both sides, because we want to undo a cube root. So we cube both sides. That undoes the cube root. I get 3y plus 1. 5 times 5 times 5 is 125. And since you have a negative times a negative, which is positive, times a negative again, which is negative, I get this. So now I'm just solving for y. I subtract 1, and I divide by 3. And we get negative 42. And then we check. So 3 times negative 42 plus 1. I'm taking that to the 1/3 power plus 5, and I want to see if I get 0. Now, I am fine with you using your calculator. Let me find mine. So if you take, let's go 3 times negative 42 plus 1. So we get negative 125. If I take the cube root of that, now to access the cube root, if you do math, you'll see number 4 is a cube root, and we want to take the cube root of negative 125, and then we want to add 5 to that, and we get 0. So check, it works. So that means this is my answer. So that's what you do on one of those. go ahead and try this problem. So pause the video, try the problem. So I'm not going to change this one. I'm going to show you how you can leave it as a rational exponent. So I'm going to add 3 to both sides first. And then this is a 1/3 power. I want to get rid of it. So I'm going to raise the whole thing to the 3rd power. Because remember, power to a power, you multiply the exponents. Well, if you take 1/3 times 3, you get 1. So you cube both sides. So you still cube both sides no matter what. So you don't have to switch it to radical form. So we get 2y plus 1. 3 cubed, be careful, it's not 9, it's 27. 3 times 3 times 3. Now you solve for y, so we get 2y equals 26. Y equals 13. If I plug in that 13, so we are hoping that we get 0. So here 26 plus 1 is 27. The cube root of 27 is 3 minus 3 is 0. It works, and there's my answer. So this one looks really complicated, but it's not. So don't let it freak you out. Notice that this is 7 times. So the problem starts right here. So we have to isolate the radical. So the first thing I do is add 4. So I'm going to leave the 7 here. It's the 6th root of 5m. Whoops, I don't know why I put that there. 5m plus 4 and equals 14. Then I have to isolate the radical, so I have to divide by 7. So I get the 6th root of 5m plus 4. When I divide by 7, I get 2. Now I'm going to raise both sides to the 6th power because I want to undo the 6th root. So I get 5m plus 4. 2 to the 6th power, I know 2 to the 5th power is 32, so another times 2 is 64. You can use your calculator if you need to. So subtract 4 and we get 60. Divide by 5 and we get 12. Now, since there's not a no solution, this would have to be the answer. Otherwise, you would go back and plug the 12 in and make sure that it works. So here is a practice problem for you to try. So go ahead and pause it and then check your answer. Okay, so take a minute. I just worked it out, and take a minute to check your work. Again, it was multiple choice and there was not an option for no solution. So, so then I chose that answer. So that should do it for this section, what you're going to need to know about it, because we're not going to do the inequalities, just the equations. So you're going to be uploading your notes, and then tomorrow you will have an assignment to show me that you know how to do this.